It may sound crazy, but have you ever wondered, if there were no observer, would the universe still exist? This question isn't just a thought experiment. It's one of the most controversial issues in quantum physics, the branch of science that explores the deepest layers of reality. It touches on one of the strangest paradoxes in quantum mechanics, the role of the observer in shaping the universe. This article will take you on a journey to uncover the mysteries of quantum phenomena, where reality is no longer fixed and objective, but seems to only truly exist when someone is observing it. Quantum mechanics. Reality isn't what we think. Quantum mechanics is the foundation of modern physics, but it's also where some of the most puzzling ideas reside. Ideas that even top scientists struggle to fully grasp. In the quantum world, fundamental particles like electrons and photons don't have a definite position until they're observed. Instead, they exist in a state of superposition, a combination of all possible states at once. This phenomenon is most clearly illustrated by the double-slit experiment. When a particle, like an electron, is fired at a barrier with two slits, it doesn't simply pass through one slit as we might expect. If there's no observation, the particle behaves like a wave. It goes through both slits at the same time and creates an interference pattern, much like ripples in water. However, if a measuring device is used to observe which slit the particle goes through, everything changes. The particle suddenly acts like a solid object, going through only one slit, and the interference pattern disappears. So what's the issue here? The very act of observing seems to change how the universe behaves. That leads to a profound question. Does reality exist if no one is looking? The role of the observer, a force that shapes reality? Based on quantum experiments, many scientists have begun to ask, is the observer an essential part of defining reality? This challenges the way we usually think about the universe, as an objective machine that exists independently of us. In quantum mechanics, measurement isn't just about recording information. It's the act that causes an uncertain quantum state to collapse into a definite one. In other words, until you look, an electron is everywhere. But the moment you observe it, it instantly chooses a specific location. This idea was described by physicist John Archibald Wheeler as the participatory anthropic principle. The universe cannot be separated from the observer. He even once asked, do we create the universe just by looking at it? Schrödinger's cat, thought experiment or deep philosophical metaphor. Schrödinger's cat is more than just a quirky quantum joke. It's a powerful way to challenge the limits of how we understand reality. In this thought experiment, a cat is placed inside a sealed box along with a mechanism triggered by a quantum event, such as the decay of a radioactive atom that could potentially kill it. According to the principle of superposition, before the box is opened, the cat is both alive and dead, existing in both states simultaneously. What's striking here is that even something as seemingly clear-cut as the life or death of a cat is determined by an uncertain quantum event. If we accept that the observer's consciousness determines the outcome, then the cat's death or survival doesn't actually happen until someone opens the box. But here's a twist that's often overlooked. What if the cat itself, being a conscious living creature, can act as an observer of its own fate? If that's true, then the wave function might have already collapsed before anyone opens the box. This raises a fascinating question about the connection between consciousness and quantum mechanics. Could any conscious living system serve as an observer, not just humans? From this idea, an intriguing conclusion emerges. If all living beings can act as observers, then the universe may not need humans to become real. It could have already been observed and thus activated billions of years ago by the very first primitive life forms. The many worlds interpretation. Every observation splits the universe. The many worlds interpretation is one of the most prominent explanations in quantum mechanics that avoids giving a special role to the observer. First proposed by Hugh Everett in 1957, this theory suggests that the quantum wave function never truly collapses. Instead, it continues to exist in all possible states simultaneously. Rather than a single reality shaped by measurement, the universe constantly branches into countless parallel worlds, each one reflecting a possible outcome of a quantum event. This means that every time a quantum event occurs, such as an electron passing through the left or right slit in the double-slit experiment, the universe splits into two or more branches. In each of these branches, a different outcome is realized. So, there's no need for an observer to collapse the wave function. All possibilities exist in parallel across different branches. A key but often overlooked point is that the many worlds interpretation proposes an incredibly vast and complex model of reality. The number of branches could be infinite, forming what's known as the multiverse. Every choice, every action, and every small event can generate a new branch, leading to countless different versions of the universe existing side by side. However, this theory also raises profound questions. If all possible outcomes occur in some branch, then what is the role of human consciousness and the observer? Is consciousness simply part of one branch, or does it have the power to select a specific path? The many worlds interpretation currently lacks a way to be directly tested through experiments, as we cannot interact with or observe these parallel branches. It also challenges how we think about causality and free will, since every decision might give rise to an entire range of parallel outcomes. Interestingly, this idea echoes certain philosophical and religious concepts that suggest the simultaneous existence of multiple realities, hinting that quantum physics might be touching the deepest edges of human perception. In this way, the many worlds interpretation offers a bold and expansive view of the universe. Yet it also complicates the question, if no one is observing, does the universe still exist? Because now, each observation might not just reveal reality, but actually create a web of parallel universes. Consciousness and quantum physics. Does the mind create reality? Some researchers, like Eugene Wigner, have proposed that consciousness itself is what causes the collapse of the quantum wave function. According to this view, it is the very act of awareness, the mind recognizing something, that transforms an uncertain quantum state into a definite reality. If this idea is true, then consciousness isn't just a byproduct of the universe. It's a necessary condition for the universe to exist as we know it. The universe can only truly be there when there is a conscious being capable of perceiving it. This is a highly controversial idea as it takes us back to idealist philosophies, the notion that reality is a product of the mind, rather than the other way around. Still, it remains one of the most profound and provocative approaches to understanding the relationship between consciousness and the fabric of reality. Reality without an observer. Whose universe is it? There's a question few dare to confront, yet it's deeply important. If consciousness is a condition for reality to emerge, as some interpretations of quantum mechanics suggest, then what was the state of the universe before consciousness existed? If there is no observer, is the mountain still there? Did the photons from a star 13 billion light-years away truly travel through space if no one ever observed them? This isn't just a philosophical puzzle. It strikes at the very core of quantum phenomena. First, we need to distinguish between two models of reality. Objective reality. In the classical view, the universe exists independently of consciousness. Physical events happen whether or not anyone is there to witness them. This is the foundation of traditional science. Observer-dependent reality. Some interpretations of quantum mechanics, such as the Copenhagen interpretation and Wigner's view, suggest that no objective reality exists until a measurement is made. Reality is locked in through the act of observation, or at least through some form of interaction that resembles measurement. But if there were no humans, who is doing the measuring? What collapses the quantum wave function? Some physicists propose that the universe can observe itself through its own internal quantum processes. For example, when one particle interacts with another, or when a quantum system interacts with its environment, this could count as a kind of natural measurement. According to decoherence theory, it is these interactions between quantum systems and their surroundings that cause superpositions to break down, even without a conscious observer. However, this theory blurs the definition of what counts as a measurement. If every interaction is considered a measurement, the line between true observation, which involves extracting information, and random interaction becomes unclear. And if that's the case, does observation still hold any special meaning? Another perspective comes from more philosophical approaches, such as panpsychism or cosmopsychism. These suggest that the universe itself may possess a kind of primitive consciousness, and that all phenomena are the result of some form of internal observation. While this may sound mystical, it's being taken increasingly seriously by some philosophers of physics, including Philip Goff and Giulio Tononi, whose integrated information theory, IIT, explores the conditions under which consciousness might emerge. In the end, we're left with a profound paradox. If the universe requires an observer to exist, but observers didn't arise until billions of years after the Big Bang, what activated the universe in the first place? This question might force us to reconsider our understanding of time itself, suggesting that the past isn't necessarily fixed and could be influenced by observations made in the present. And so, in the quantum world, where space, time, and reality can all be delayed, fluid, and dependent on perception, the absence of an observer might be the same as the absence of the reality we know. But then again, maybe the universe still exists, like a symphony waiting to be heard for the first time. From quantum to cosmology, did the Big Bang need a witness? To understand the link between quantum phenomena and the origin of the universe, we need to explore how quantum principles might influence the cosmos on a grand scale. The Big Bang, the moment that gave birth to space, time, and matter, is typically imagined as a purely physical event, independent of consciousness or any observer. But some theoretical physicists suggest there may be surprising points of intersection. John Archibald Wheeler proposed a bold idea called the delayed choice experiment, extended into cosmology. According to this concept, our present-day choices about how we observe the universe might influence how the universe unfolded in the past, indirectly, through the quantum nature of time and information. Specifically, Wheeler hypothesized that our current observation of ancient photons from the early stages of the universe could, in a quantum sense, cause those photons to choose their paths at the moment they were emitted, even if that moment was billions of years ago. This raises a staggering question. Could the entire history of the universe, including the Big Bang itself, depend on measurement conditions and conscious perception in the present? Is the reality we observe today not just the product of objective physical laws, but also the result of it being perceived, being named, by conscious beings? Some have even speculated that the Big Bang wasn't an absolute event, but rather a quantum phenomenon that required the collapse of a cosmic wave function, a process that might necessitate an observer. If that's true, then the very act of our existence and observation today could have activated the past, a paradox that challenges every classical notion of time and causality. While this hypothesis lies beyond our current ability to test, it opens up a fascinating perspective, that the universe's birth was not just the beginning of us, but also may have depended in some deep way on us. Conclusion: does the universe need us to exist? So in the end, if there were no observers, would the universe still exist? The answer remains unclear, but one thing is certain. Quantum mechanics has forced us to reconsider humanity's role in the cosmos. We are no longer merely passive spectators. We may be essential to the universe's very being. As physicist John Wheeler once said, "No quantum phenomenon is a phenomenon until it is an observed phenomenon." And if that's true, then the universe's existence may not be a given, but rather a strange, ongoing story that only becomes real when someone is there to hear it. And if you are still listening, then perhaps you, right now, are creating part of that universe.